Just I'll let you know we can't hear you online.
Okay, I presume that was what was in the chat was that.
Yes, now we can hear you.
Okay, cool. I can't, if someone can keep an eye on the chat and on Slack and like holler if
Yeah, I don't want to holler because I heard sometimes the speakers are very loud in the room.
we've turned y'all down. So, um,
Okay, good.
okay, so this is, yes, I have slides, but it's really just summary. Can somebody throw, these are in the, this isn't the summer school. These are in the meeting folder. So if somebody can throw the link into the Slack just so people have access to it. Julie, can you do that quick? Um, yeah, just because there are links to the GitHub discussion in the slides, and rather than copying all of the GitHub discussion into the slides, I figured that was probably better. Um, so I think I will run through this kind of in the order that it is in here forward, and then we'll run backwards because that's sort of what people want to talk about. There we go. Okay, so this is just a bunch of things related to ongoing standards process, FEPS and such. The simple one that we can probably take offline was Julie went and wrote FEP4 and accidentally did a table, um, which is not common work, which we had specified. Um, I think the important thing is we're not going to be voting FEP4 because you're frantically rewriting it based on conversations yesterday. We're not voting FEP4 today. So, so this doesn't need to really be resolved until we're ready to vote FEP4 and we can take about it. So look at the GitHub on that, and we can think about, do we stick with strict common mark and deal without tables? Do we actually do a formal switch over to like missed markdown or something? Do we just cheat? Or do we do some sort of formal escape hatch where if we run into weirdness with procedures, we just vote that we're skipping the procedure that time around. So that's in the GitHub discussion. This one, I think, does anybody object to the idea that we're going to be writing a bunch of FEPs to ultimately replace our standards, and the standards document is going to substantially change in its significance? All right. I'm not seeing anybody say disagreeing. Um, so that's kind of the rest of the talk here is the first thing supposed to. It would be good for folks to take a look in the next 3 hours. So I guess at the break, look at FEP3 because Sean is doing something kind of interesting in there. That's basically looking at as we replace various standards with FEPs, updating the standards document to note that. So we'll probably do like a rolling update of the standards document until it's all FEPs and then cut it off. But there's variations there. Again, this isn't something that needs to be resolved immediately, but it's worth taking a look in case you have comments on the way Sean approached it in FEP3. That's probably the important thing. And yeah, I think our discussion yesterday has kind of come down to, as we write these standards, we'll need to specify the tiers on that. Which actually, Sean, before we vote FEP3, you might want to very, very quickly edit in at the top of it that says, this applies to bronze and higher. Just something to stick in your ear unless you want to discuss that. Right.
Yeah. Sorry, I needed
Chicken
to grab
egg.
a microphone to respond to that. I'm gonna lean against that for now. I think I'm getting a weird look. What?
No, you're not getting a weird look from me, but
yeah, no. I think I'm gonna lean against actually specifying a tier for what the FEP3 applies to. I like the approach of just having FEPs just be their own standalone rules, and then like FEP4 can describe what the tiering thing is gonna do.
okay, so we will defer that, and if we need to peanut butter over it in FEP4, we'll do it then.
Yeah. Especially because FEP4 doesn't exist yet. It doesn't really make sense in my mind to call out package tiers when we merge this.
When they don't exist, yep.
Yeah. No tiers are mentioned whatsoever.
No, the only reason the reason I bring it up is because Stuart's idea yesterday, which I think makes a lot of sense, is for standards track FEPs to say what tiers they apply to.
I had forgotten that.
Yeah, but we can always peanut butter over it, right? We can say in FEP 4, if a FEP doesn't specify, then it's applicable to bronze and up or something like that. Yeah, Strauss says FEP 4 can just retroactively add it because there will be very few at that point. It can just say. Well, I mean, ultimately, we just spend the next 3 years writing everything, getting it perfect, and prove it all at once. But maybe we want to get something done in between. Sure. All right. Anything on this before we go into the details? All right, so I will run forward quick and then backward because that's how people want to discuss it. So we have existing community standards that we declared as kind of community categorized. We have license. I think we had agreed yesterday we're probably going to drop the license out of FEP 4 and into like a licensing one. So my suggestion would be to lump these together into a FEP that talks about community, talks about licensing, talks about governance potentially. And just summarizing kind of the changes I was suggesting there is your version control has to actually be public. We don't technically require that. Open design, getting user input, some sort of licensing details, and requiring reporting procedure for code of conduct violations. Documentation standard. This is probably going to be a small one, but just a couple of suggested changes of you only have to document the public API, explicitly adopting PEP 257 for doc strings, and just having information on how your documentation works as part of your documentation. And then finally, testing maturity standards. This was 2 categories that we had on our evaluation page, our package evaluation page, that kind of lumped together and suggest breaking out in a different way, having a FEP describing our packaging standards. So packaging releases, OS support, and then one on development practices. So, doing PEP8, doing stack analysis. And then each of those I have some suggested detail changes. But since this is the category that most people voted for, let's start with our detailed conversation on this. So starting with Zoom, let's see, do I get to see hands of people? I probably don't get to see hands. Can somebody watch the hands on Zoom? So we'll just say, we'll do hands for people who want to talk packaging. And we'll do hands in here. So if you want to talk packaging first, hand up in here or hand up on Zoom. Deaf. Anybody on Zoom? Okay. So by default, then we'll talk development practices first, unless anybody. Okay. Okay, cool. It's probably going to be easier if people just bring up the GitHub discussion themselves so they can scroll around and take a look at things. Because trying to project that is probably going to give me motion sickness. So the stuff I threw out there is just, hey, static analysis tools are great to have in your continuous integration. Please have some documentation on how you run your tests. Think about data coverage. And just sort of updating our don't check in binaries. Like if for whatever reason you have to put check binaries in, have some source because we're open source. So I will throw the floor for this or any other thing. So people have thoughts on what we should be requiring in the category of how we go about our development practices.
Yeah, and just to make this easier, I'll go ahead and paste a link to the actual GitHub issues in the Zoom chat.
Yes, thank you.
Too, so people can quickly go to that if they don't have the slides pulled up.
Because I'm pulling it up on my phone now, so I have a place to look at it. But
Hey, Nick, go for it.
Awesome. For static analysis, is this things like linters and such, or does it include things like MyPy for static type checking?
It's pretty vague. We can define as much as we want. It's just I think we'd agreed static analysis is a good thing, and if we're doing it, having it in the CI is a good thing. So that can be shoulds, that can be suggestions, whatever you think.
Okay, cool. Probably for different tiers, different static analyses.
Yeah, that may well be appropriate.
I worry about specifying different static analysis because specifically static analysis tools, just because that ecosystem moves so fast.
Mhm.
So like I general things like, you know, you should run a linter, you know, if you know, type hints are a thing. I don't know. I feel like I don't know. The static analysis thing is interesting. I feel like, it's probably good to document that various static analysis tools exist and people might want to use them. I kind of worry about requiring any of them just because it's a malaise of stuff that moves around too much. Um, I guess we could say something like, should use a linter. I, I'd even be a little bit skeptical about saying should use like any type hints because I think that's probably a bit more contentious. Um, but then saying that they exist is a thing that might, teach more people about it. So there's some utility there, but I don't know.
Is this something that makes more sense as like an informational FEP?
Maybe it doesn't need to be a FEP at all. Maybe we just need some kind of packaging guide, or we just point people at the scientific Python one or something.
Yeah, I think I want to go ahead and read out what the current standard is on this because it's just one sentence.
Yeah, go for it.
It just says projects must adapt the basic style recommendations of PEP 8 and static analysis tools should be used to identify deviations from the basic style recommendations. And then it says, e.g. PyLint, Flake 8, PyCode style. So we only have that one sentence is like what we're currently recommending. And I'd be okay with not going all that much further than that, like Stuart is suggesting, but just saying like, recommend using static analysis of some kind. Don't specify which.
Yeah, and to be clear, the main thing I'm suggesting adding here is to say, put it in your CI.
Putting it in the CI actually would be a great recommendation that we are not currently doing. I'd be in support of that. That could be something where like in the reference implementation section of the FEP, we could like have a quick little example of how to do that with like GitHub Actions, for example, just to give
I like
people
that
like
idea.
almost a copy pastable kind of, here's how you run that in CI.
I mean, I imagine that this. Sorry, go ahead, Stuart.
I was just going to say, I'm sure that's somewhere. Like, I'm sure we don't need to write that content. We can just link it to
Yeah,
somewhere.
in terms of reference implementation, I am guessing we probably have at least one and probably two or three of our projects that are already doing this, and we can just say, look at this existing PyHC project.
There's a very nice page in the scientific Python documentation about it. I will throw it in Slack.
Thanks. All right. Anything else on static analysis? That was also connected to our coding standards. Do people feel the need to go beyond PEP 8?
I'd be happy stopping at PEP 8 personally.
All right.
What, just as a thing, what is this going to be a must? Is this going to be a bronze level FEP? Like, does people think that all the musts in this should be everybody?
Whatever. This is, I am not at the point of writing anything here. This is why I was just throwing this down to start the conversation. I don't feel we need to add complexity here if nobody's feeling the need. What I was suggesting was largely small changes to what we have in the standards document that kind of reflect to a large extent what we're already doing. But if we're also saying what we've got there is pretty good and this isn't urgent at any particular tier, then let's not. Because I mean, I'm sure Nick would happily use more time for conversation if we don't have too much to discuss here. All right, if there's nothing online, I'll push on it. And Sean, sorry? Okay. Sean, I think you've got the right ideas, bringing back. Okay, so on testing, we have a standard, there must be unit tests in the repository. They should measure coverage and target reasonable code coverage, should use continuous integration, and should have procedures for acceptance and system testing. Right now, we don't really have details on acceptance and system testing, and I'm not sure too many of us have a detailed process for that. The other things I was suggesting adding there is just, like I said, document how to run the tests and consider data coverage and not just code coverage.
Yeah, I personally think just having the how to run the tests would be a super helpful thing already, because I've run into problems with that myself, trying to like run unit tests of PyHC packages, and I look at the thing. I've even had to, I think, email you before and be like, John, help. So that'll be good. And we were just having a conversation yesterday before dinner about how great it would be if packages that have unit tests also were measuring code coverage. We started to talk a little bit about like maybe requiring a minimum like code coverage, like you should have at least 20% of your code covered or something. But I personally feel like just it'd be a win just to have people create the mechanism to measure how much code is covered by tests.
Are you thinking of that just on an ad hoc basis, or should we be recommending it be in CI?
Probably ad hoc, but I also haven't necessarily used that many code coverage tools, so I wouldn't be the one to ask how to implement that.
I'm wondering, how are you guys thinking of testing the test coverage? Like, is it done locally or is it done through like, I don't think we do this. Yeah, we also do it in the CI/CD on IMAP. We also do it right before a PR. So like when we open up a PR, we make sure that it has like at least 80, 90 test coverage. So like, I'm wondering what the process is from you guys' perspective.
Yeah.
Deciding now.
Yeah, we currently don't have a process for that. So I don't know if there actually is an answer.
The process is we assert we have adequate test coverage. I mean, what I personally do is I literally just run coverage on the entire code base, find the smallest number, find an undergrad, and say go. When that number gets up between 80 and 90%, I say thank you very much, open a pull request, and we look for the next one. But I like the idea of encouraging folks to do this at PR time as the code comes in. Because I think that also helps make it more friendly for new contributors. So Tenzin, I may poke you for the details of how that's set up in IMAP so we can potentially use that as an example.
Well, something that's interesting. I'm over here looking at our standards document, and we actually do have a few sentences on testing, and one of them does say testing coverage should be measured, period.
Yep.
So apparently we've been recommending that for a little bit, but we
Yeah.
haven't gone very far towards enforcing that.
With no details on how much or how.
So a FEP covering the testing could just be a little bit more specific and, again, have like a reference implementation for someone who's doing it well, that kind of thing.
Yeah, this might be something where even if we don't change the standard much, but mostly include reference implementation, how to teach that information, that might help. Other thoughts on testing?
I'll just point out that Nick put in Slack something to CodeCov, which is a quite useful CI tool for measuring code coverage. And I'm going to go ahead and drop a link to that in the GitHub issue too, so we don't lose it.
Yeah, thanks. I was seeing a number of folks using it. Nick, do you want to give like a 30-second spiel on that?
Yes, I'm totally prepared to do that.
Do you need to share slides?
No. So, when you run PyTest, it's possible to add in a coverage option with like there's a PyTest extension that does that, and it'll measure like which lines of code are covered in the test, or by running the tests or not, and then it'll give an analysis that shows up as a comment on the pull request, and that'll show like in the pull request of the lines that were changed, which ones are covered by tests and which are not. So it helps to identify like lines of code that were not run by tests, so untested code, or sometimes even code that's never going to be run.
Is that PyTest only, or is it compatible with other unit test runners?
Good question. I've only used it with PyTest.
And I was looking at it and was a little confused by, I mean, obviously there's reasonable support free for open source projects, but it looks like there's still some limitations.
I've never run up against the limitations.
Okay.
It is a little finicky at times, I will admit that. But yeah, I haven't run into the limitations.
Cool. Other thoughts?
This is pure speculation, but on the CodeCov website, they have a languages section that extends way beyond Python. There's like, I don't know, 20 different supported languages. So I have to imagine they support more than just PyTest.
Cool. Okay. All right. Okay, so the only other things I want to mention is if we want to talk about like acceptance and system testing and put any more information on that, if people want to come up with thoughts offline. And I like having some notion of data coverage. It's much harder to quantify, which of course is why it tends to get left by the wayside. So the question is, what do I mean by data coverage? And that's, so code coverage is just if the line gets hit, right? And the state at the time the line gets hit will affect the output of the line. So for instance, if you do the stupid thing and build up a list by doing a bunch of appends with conditionals in the middle of the loop, and that conditional is never hit, you'll see that in code coverage, right? Because that branch, that code never gets run. If you then do the smart thing and turn that whole thing into a list comprehension, now it's one line, and the line still gets hit, but you may never actually hit that conditional. It may always be true or always be false. And so I believe there are some formal tools for evaluating data coverage, but to a certain extent, there's just some manual look at and go, is this line going to behave differently based on what's there? So that's why I think it's worth raising as a consideration. And again, if people have favorite tools for that, that's awesome. And I'll add that note into the issue. Okay, the other two things that we had kind of in this category were binaries in the repository and dependencies. I am tempted to say let's not talk dependencies unless people really want to, because that kind of connects to our interoperability discussion, that kind of thing. And the notion here of the dependencies is just we kind of have something that says don't add dependencies you don't need. I guess the real question is, do we even need that standard anymore? Do we want to just kill it? Are we having more of the opposite problem?
I mean, I would say FEP3 is becomes our official rules for how to handle dependencies. So that's already covered by the FEP that we're voting on later today.
About dependency versions. What dependencies you have, by the way. It's like dependency versions, not what dependencies you have. The line in the standards is about not having unnecessary dependencies.
That's a good point. Yep. Current standards say projects should import the minimum number of packages necessary. Adding new dependencies should be a considered decision.
And to be fair, in 2018, that was maybe a little bit more difficult.
Yeah. I feel like that's good enough for now.
All right, so we maybe can even get rid of that one. Anybody want to say anything about checking binaries into the repo?
Don't. Yeah.
Agreed.
Don't. Yeah, our current standard says to only do that when it's absolutely necessary in order to keep the package running, basically.
You're talking about like test data or compiled code here.
That originally came up because of Jupyter notebooks. And I mean, I certainly, like, SpacePy, we've got some small CDFs checked in, they're binaries, but it's, to actually check that. And again, this isn't a blanket prohibition, but it's trying to avoid having gargantuan blobs that you can't see the history for, and that potentially you don't know where they came from, right? Which kind of violates the open source principle.
I have two parts question. So first one is the dependency, is it different from and that might be going into the next topic, the packaging, like when you're creating a package, including all of the dependency it needs in that. So, and that's my first question. And my second question is the binary files, like the testing files, the data files, if that is like on IMAP, we have a limitation. So like we say you should not have data in your test folder more than like a certain file size, so that you limit, but you also have like a good data included already in the repo for other user to see and test it locally for themselves.
I wonder if we could add some sort of language about if possible, if you can generate it on the fly, basically, then do, right? There's some cases where you can't. Like we have some test like FITS files, or we have some FITS files in our repository that we use for testing that obviously we can't generate data on the fly. But then there's some cases where we just need the header, and so we just generate we just store the header basically as like a dictionary, and then the data is just sort of like a dummy array. It doesn't actually matter what it is. But then there's some cases where we actually need to test the data array itself. So we keep the minimum set of those possible.
So some size restriction sounds like a reason. I mean, if we say 2 kilobytes, somebody's going to want 2.01, but
I think just within reason. I mean, something that doesn't, make your, I don't know, your git clone or whatever slow to a crawl. And I guess also, I mean, you just because it's included in the repo or in your like when you do a git clone doesn't mean you have to include that in your installable binary either. Like there's probably at least on like for testing purposes, right? There's no reason that a user should be getting shipped all of your test data, right? Unless you also want to run the tests. But yeah.
That's an interesting question, right? Because we were talking yesterday about, do we want to have our tests come in when we do the pip install so that Sean doesn't have to go cloning the repo? And then in that case, we kind of do need to ship the data.
It could.
Yeah, I mean, if you had lots of tests that needed like a significant amount of data, you could skip those if the data wasn't present or something. Like you could work around that. I don't think we need to standardize all of this. I think we need to like again, and I'm sure all of this is in like existing packaging guides, primarily the scientific Python one. Again, we don't need to even document all of this ourselves, right? We should just make the resources that exist available to people. I I think like it's easy to have these conversations and to like talk about all of this because it's stuff we care about, and like educating the community about all of this stuff is good. But I don't think we need to get this far into the weeds in terms of what we're actually putting in the standards.
So one of the things we could do is, I mean, I can go back, look at what we have here, which of those are duplicative. And if we have a very short standard that says packages shall follow the scientific Python packaging guide. Sorry, not shall, should.
Maybe. Yeah.
But, and Tense, I want to address your other question too, which is, it sounds like you're asking about bundling dependencies together with the package. Yeah, okay, guilty, but I'm bundling Fortran, so yeah, that's not been an issue. The standard was just plain literally how much stuff do you import, and try to avoid importing a bunch of stuff. Cool. Anything else on like development practice and that kind of thing? All right, let's go back to packaging standards. Per Stuart's suggestion, maybe we just get rid of this and look at existing resources.
I think some of this we should standardize, right? Like having a proper build PEP 7518 compliant build system, binary wheels if necessary, a version scheme, etc. I think all of that is stuff that is like table stakes for a functioning Python package. So they should be in a standard and required for everyone because.
At least for the silver and gold levels, we were talking about having PyOpenSci be our review process, and I know they have packaging, like that's their thing. Do we want to see what their standards are and just use those if that makes sense?
Yeah, actually, Nick had just dropped a link to the PyOpenSci packaging guide in Slack.
There you go.
There are so many packaging guides in the world.
Well, this is true. If we're partnering with them, though, that would make sense to try to adopt similar things.
Are you suggesting we adopt those, or we just say, thou shalt do what they say? Take a look and say, okay. Okay, so one of the things I can do just in terms of spade work is, as with the Scientific Python Packaging Guide, look at the PyOpenSci package standards and see what's different with ours and see if that informs ongoing conversations about what we want to explicitly require. So just to skim what we've got, right now our only requirement is it has to be installable Python package. It's a start. So then, I suggested going to modern build. Right now, we currently say we must make releases on a regular basis, and we must be on PyPy and should be on Conda. That's what we currently have. And the suggested addition is I should deliver wheels, including binary wheels, and have a consistent versioning scheme. OS support, what we say is we must support Linux, OS 10, and Windows. We don't have any architecture support requirement, which we might want to talk about. I suspect that's going to continue to be interesting going forward. The Mac ARM transition is probably pretty close to done, but Windows ARM transition, my guess, is going to come along at some point, more than it already has. And RISC-V is always over the horizon. Maybe always over the horizon, but
It's like fusion.
no, cold fusion is always getting further away. Or it's not cold, but energy producing fusion.
The architecture support requirement feels like it's simultaneously very nebulous and potentially very onerous.
Yeah, I think it's pretty obvious that we all had to transition to Mac ARM because we wouldn't really be supporting Mac if we didn't. But
like I spent a chunk of yesterday figuring out how to build AArch64 wheels for Stream Tracer on GitHub Actions native ARM runners, because if you emulate it, it takes too long and the builds were being killed. Like,
do we finally have native ARM runners
pay for?
Pay for?
Yeah.
Oh, you do have to pay for them,
but they're not very expensive. So like there's a lot of work to do architecture support, especially if you're gonna try and ship binaries and stuff. Like it's not like impossible or anything, but it is potentially challenging, and I would be hesitant to like require that of anyone.
Yeah, and we definitely don't want to have we require Linux support. I think Debian just dropped their S390 architecture support. So, we wouldn't want to be dealing with that.
It seems like this question of building binaries, and in particular, building binaries across an arbitrary number of OSs, and especially for packages with compiled code, is something that causes like a lot of heartburn like across this entire community. And it seems like this should be something we should be trying to come up with at least a way to support packages within this community. I don't know really what that means. If that's just like having a recommended guide that we point people to, a recommended set of, whether it's, I wouldn't suggest us setting up our own set of instructions, because it's just like anything with packaging. There are a million different ways to do it, but settling on some sort of recommended guide for building wheels in CI, because it is possible. It is not the most trivial thing, but there's a lot of existing tooling and fairly new tooling, honestly. Like this landscape has changed dramatically since we had this first meeting 6 years ago, right? Like this is a very, very different. Basically every part of it is different. And so it is reasonable to be confused by this, but I think this is clearly something that affects almost everyone in every core package and a lot of packages within PyHC. I think that this would be something really concrete that we could do, is to come up with, or just to settle on a guide that we recommend to people, and then maybe, in some way, like provide support to packages who are really struggling with this, because it is doable. It's not trivial, but it is very doable.
So I'm going to riff on that with a couple of suggestions. Sounds like we probably don't want to be going down the road of trying to come up with a perfect list of musts for architecture support. As we have whatever our packaging standards are, there will be some how to teach this reference to like PyOpenSci packaging standards, and probably then also include like reference to CI build wield or something like that, whatever reference. So that's so don't worry about the standard, connect the education to the relevant standard, and think of some community support thingy we can do. Maybe half-day hackathon or something like that. Anything else on packaging? Anybody online? I think everybody's tired. So those are the ones that people most want to talk about. So I'll keep walking backwards here. Anybody want to talk about anything in documentation? Again, this may be a case where how-tos and education are more useful to us than more standards.
Yep. One sec, I'm actually reading over what our current standard says, so I'm reminding myself what the current situation is.
Sure, I'll read all the current one. All functions, classes, and modules must have documentation strings, doc strings, provided in a standard convention, e.g. NumPy doc. Doc strings must describe the code's purpose, describe all inputs and outputs, provide examples. High-level documentation must also be provided as guides, tutorials, and developer docs. Documentation must be provided in version control with the code and be made available online in a readable form.
That's already pretty good. I mean, one thing that I was presenting on Monday is, how I was starting to unify some of the documentation with like the read the docs search across projects feature. And obviously it would make my life nice if everyone just standardized on like Sphinx and read the docs documentation, but I don't want to make that a requirement because other people do have really good documentation that is built on other platforms.
You don't have to use Sphinx to use read the docs, and you don't have to use Sphinx on read the docs to make read the docs search work.
Oh.
So you can use any documentation builder on read the docs now. Yeah. Read the docs has become a generic CI system. I kind of think that none of the shoulds you have on the screen need to really be mentioned at all. I think something more concrete like we have in the current standards is sufficient, right? Like you must have documentation and it should cover all of this and this and this. And like I think what would probably be quite good would be to make this documentation standard pretty hard, like have quite a few musts in it and make it pretty robust and then stick it at silver or something.
But like how do we include some language such that, like sticking a static PDF straight into your repo isn't sufficient enough to like satisfy this standard, right? I mean, I agree that I don't think we should get bogged down in like the kind of specifying like what tools people are using. On the other hand,
I mean, right now the existing standard, if you're saying we want to base off the existing standard primarily, that requires doc strings.
I think adding a must build documentation. I would have to wordsmith. This is not the time to wordsmith this, but adding something along the lines of you must build your documentation into a website and host it on the internet would also be
documentation must be made available online in readable form.
Does that exclude PDFs dropped into the repo?
If you somehow can manage a PDF dropped into the repo that you have built out from your doc string, like if you really want to be that stupid, that's probably compliant.
What is the exact wording on like how dynamically building it?
Let's see. All functions must have doc strings, must be provided in version control, and must be made available online in a readable form. So we don't explicitly say it has. Okay, so here's my suggestion. Sounds like there's not any appetite for doing this nonsense.
I think there's maybe we could add a should put it on read the docs if there's like if we're going to work towards the having a global search thing. We could do that, but or we could even make that like we could add a line in the standard somewhere like to be included in the PyHC search documentation search system. You need to host it anyway, whatever. But yes, other than that, no.
Any of this stuff that we want to change? And right now we're requiring that you document the private members. Yeah, we're saying everything has to be documented.
Load up the old stuff. The old gods. Classes and modules, yeah. The only problem with saying public API is that is a hard thing to define concretely in Python.
Does it have an underscore?
That's a very strict interpretation of public API. But we could be okay with that ambiguity, right? Like that's not necessarily a problem.
I think I'd rather have that ambiguity than have you haven't put a doc string on this helper function that's 6 layers deep and nobody's ever going to call.
Someone will call
it. And I want them to know that the suffering is on their head.
But yes, I think all of those are good. And I think add some language about building it into a website somehow.
Okay, this seems like a fairly easy one for me to do some potential wordsmithing.
Saying none of your shoulds, I think the CI thing it should be a should. If we're going to require dynamically built documentation, we should have a should for do that in your CI. Okay.
And I think I need to look more into the read the docs thing to figure out how we can link to other kinds of documentation that isn't Sphinx. Because if I can start to pull in other documentation that isn't based on that, that would be sweet. And I like the idea of having language inside the FEP that, just like you recommended, Stuart, says, if you want to be included in a cool global search thing, here's connected to read the docs or whatever, have like a quick how-to for that.
I will just reiterate, please do not take other packages documentation and build them on read the docs. You have to migrate that package to read the docs.
Oh, absolutely.
Okay.
Yeah, I think it would be interesting to have, not now, but in the future, a conversation about the trade-offs between self-hosting versus read the docs versus both. And it'd be interesting to hear people's experience with that.
Oh, and it's a non sequitur, but just on the topic of copying documentation, I have already told Google to not index my current prototype of the documentation thingy.
Awesome.
Cool. We talked a lot about licenses. Do we want to talk about licensing? Do we want to talk about community? Do we want to talk about governance?
Thank you. Did we land on definite solutions for licensing? We could talk about it in Telecon or now, but we should talk about it at some point. Chirp, 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 chirp.
My thought was we had a lot of back and forth yesterday, and several folks have thrown out some resources and some ideas. And I personally feel like I'll probably have more informed thoughts in a week or two when I've had a chance to have it settle. Are other folks feeling similarly or feeling differently? Okay. Stuart, did you have a? Okay. Anything else on community and governance that we want to go over? And this feels like the type of thing that we can probably do offline. This we talked about. Do you want to talk about tables or do we want to hand it over to Nick?
I do not want to talk about markup in any way, ever.
All right. Julie wants to know if she should keep her table.
I think we should have some support for table because
Okay,
I can see that coming up multiple times.
Yeah, dear God, please don't remove tables as a possibility.
And
we
also,
did- we-
HTML source is also not acceptable.
we removed it already 6 months ago. We agreed to that. Now the question is, do we add it back in? I think the
did
answer is
not
yes, we
realize
add it
I
back in.
Did not realize I had agreed to that at the time. I was naive.
You didn't read the entire common mark spec?
And this is why restructured text is better than Markdown. And that is my hot take for the day. I'm out.
Okay.
Because it actually has a specification.
So does Markdown's common mark. So, okay,
No,
I think
Markdown has 70 specifications.
Oh no.
Okay, do I just need to pull up the XKCD now? Okay, so Julie, I think the answer is you get to keep your table and we're going to figure out how we're going to do it later. All right, that is all I wanted to talk about and then some. So how do we want to do this? Do we want to break early or do we want to have Nick start his conversation and then we have a break a little ways in?
I mean, ask Nick, right?
I suppose, yeah, his input's valuable.
I never mind a break. Um, it probably would be good to have this conversation in a single block of time.
Okay, yeah, we'll just break. Still not a super long one, 15-minute. What time is it now? It's like 10:55, so come back at 11:10? Mountain time? Not your time?
Maybe 10.
Sorry, 10:10. Oh my God. I can't math. 10:10, 10:10, please. It's 9:55, not 10:55. GitHub issues and so forth. All right, thank you.
Yes. So the issue we've all been waiting for, not going to be contentious at all, is an issue I raised on GitHub a couple of weeks ago. And the idea that I've been tossing around is writing an exploratory FEP, which hopefully is less controversial, on a new package that's designed for interoperability with AstroPi and hence SunPi and PlasmaPi. And as Julie mentioned in the in Slack and the Zoom chat, there are links to things and for emojis. All right. So the premise, the place where I'm coming from is that there is significant need for a space physics package that is highly interoperable with AstroPi. And the reason is so that is like, as I mentioned earlier, that in order for something to be interoperable with SunPi and PlasmaPi, it's also going to need high interoperability with AstroPi. So the idea is that with this new package, we can have at least a subset of the PyHC ecosystem have AstroPi as a baseline for the interoperability layer. So I want to mention the AstroPi interoperability skyscape. So PlasmaPi and SunPi, both since I think their beginnings, or at least early on, have both been developed to be interoperable with AstroPi subpackages. For PlasmaPi, it's somewhat limited. We make heavy use of the unit subpackage and constants, but there's some potential for using AstroPi time, AstroPi modeling, and other things potentially. And SunPi has a lot of dependence on AstroPi, units, constants, coordinates, LECS, like world coordinate system, time, visualization, logger, and IO. There are also some converters in packages like SpacePi, conversion to, and I think from time, skycoord, and quantity objects. I did a search for PySpeedS and saw that it used AstroPi for some coordinate Cartesian to spherical coordinate transformations. And then Komodo has some constants, uses some constants, and then has some converters also. So that's the current skyscape. And there are a couple of paths forward if we accept the premise that there is a significant need for a space physics package interoperable with AstroPy. The first is to modify an existing space physics package. This would need potentially a major rewrite to rebase the code base on AstroPy objects. And to do this, we need significant time investment, specifically, most likely by the core maintainers of the package. And this would likely result in a lot of breaking changes. Another possibility would be to create a new space physics package and design for gold interoperability using PlasmaPi's particle class with AstroPy. And this also would need a very significant time investment, but it's possible that it could act as the front end to other packages, so make use of functionality in SpacePy, PySpeedS, PySat. But we also need use cases to figure out what the functionality should be. So I started coming up with a couple. One is based on the last time I did observational research back in like 2011. And this would be a use case that combines remote observations of the sun with in situ observations of space plasmas. So for my research back eons ago, I was performing non-equilibrium ionization modeling of coronal mass ejections. And the idea was to see how the ionization states changed in response to heating and then match it to observations. Excuse me. And doing that would give us an idea of how much plasma is heated and where. And in this use case, I might have in situ data from Parker Solar Probe or Solar Orbiter, and then remote observations from the Solar Dynamics Observatory. And this could be like older observations also. The crux of this issue is that I need to match blobs, plasma blobs that show up in the remote observations to in situ observations. And to do this is what needs to be done to be sure that the plasma is the same plasma. There's another use case where I would have in situ observations of the magnetic cloud, and often magnetic clouds are fit to a force-free flux rope, which is essentially given by the Lundquist solution. And in this use case, I would expand the capabilities of PlasmaPi's force-free flux rope class and implement AstroPy modeling so that we can do fits to using like observational data to this formulation. And in this case, I would read the in situ observations into some sort of plasma data object and feed it into a force-free flux rope object for fitting. So in one question that I have is, should we create a space plasma equivalent to SunPy's map class? What map does, and people from SunPy can feel free to jump in, it holds 2D data with fits compliant metadata, and it allows us to do coordinate aware operations. And these are built on SunPy coordinates, which are built on AstroPy coordinates. And map serves as a common interface for 2D data products. So if you want to read in a SDO AIA observation, you can use it with the same class to get a Hinode XRT observation. And it like picks the correct subclass. So it acts sort of like as a class factory. But we could create something like plasma data, probably need a better name, to be a space plasma equivalent to map. And this would be essentially a common interface for in situ data from different space missions. And this would be including a whole bunch of different fields like magnetic field, number density, temperature, and so on. If we do this, we could use some of the API from map. So map has a peak method, which allows us to take to do a quick look. And there are also things like observer coordinates or something like that. And a possibility would be to inherit from new plasma objects in Plasma Pi. And then if we do that, we could potentially let Plasma Pi formulary functions accept plasma data objects as arguments. And so this would be a great help for interoperability, because right now there are a few intermediate steps that are necessary to put space physics data into Plasma Pi formulary functions. So here are a few questions to start off the discussion. The first is, should we continue exploring the idea of a new space physics package designed for interoperability with AstroPython Pi and Plasma Pi? And along with that is a trade-off analysis. Like, how do we manage the trade-offs, or what are the trade-offs between creating a new package versus modifying an existing one? And the last is, should we go about doing a PyHC user survey to figure out what the pain points are that the users of our packages are experiencing? So for this discussion, I think it's important to keep in mind the code of conduct. And yeah, so let's open it up, and hopefully Julie can moderate everything.
Yes, that's the goal.
Okay, so yeah, the obvious. So first off, I want to apologize. I need to bug out in about 20 minutes, so that's not going to be because of anything anybody said. So I'm going to say general things and then probably just sit back and listen. PRs welcome, issues welcome, right? Like, I am totally happy to write converters. I'm also would love to get into places where we use duct typing more interestingly, right? Where, sorry, I'm speaking specifically space Pi, in case it weren't obvious, where, if you're passing in objects from outside of space Pi that can be interpreted by, in a reasonable way, right? Like throw AstroPi time at anything that space Pi requires a time. I would love to have that work properly. The more I hear about what specific things people need to do, the better I can prioritize and not just go based on what I think is cool. It's interesting that you kind of headlined this as like a new package, but what it sounds like your focus towards the end here is thinking of a somewhat higher level data object, which I think is pretty cool. Our kind of hibernating data models work does include going to and from NDCube. If that's no longer the right target, then we should think about that. But if we have some existing thing in the ecosystem that's a really good target, again, not a let's rewrite everything to only use this, but hey, this seems to be a good thing that's our common basis, that would be awesome. I'm obviously less inclined to say pi speed s plus space pi plus pi sat isn't enough. Let's do something fourth from scratch. But yeah, so that's kind of my party line. I'm very interested in just hearing what else folks have to say.
John online, go ahead.
I think you're muted, John.
Thanks, Will. Yeah, there's ways we've thought about trying to come up with these sort of higher level data representations. Originally, that was part of what I wanted to have in Happy, but it was way too complicated for any kind of initial version. But if you have things already arranged in a table, then how you interpret that table it can tell you the semantics. Like, oh, this table has mag data. This table has plasma parameters, density, temperature, velocity. This table has energetic particle data. It's starting to get pretty complicated. But if you had ways of internal data models for those kinds of things that you were targeting, then there could be adapters. To adapt this table to um, to the specific mag representation, here's what you do. And so we came up with this concept of what we called science data interfaces, where it's just like an API for a specific kind of science data. And then it's that same data model concept again, where it's like, who cares how this got in here? Now this is mag data, and we could use it that way. So I'm not sure how compatible that would be with like the plasma data object that you were saying, but that's something we could talk about. Is there a way to, it's kind of like a semantic layer on top of an existing data model that then lets you know this is a particular instance of something. And then certain things always become true, that people name mag data variables, all kinds of stuff, but in the standard API for mag data, it would always be this, and it would always be nanotesla, or it would either be, one of a small number of units. And the vector would always be represented this way. And, you could convert it to something else because once it's in the standard way, then the mappings become easy. So that's kind of the way we've thought about it. And it's requires a lot of work to map things into a standard. Um, but you could start with low hanging ones, the easier ones like mag, which is just, much simpler than particles. So those are some of the things that we've had. We've done this in Java. We have science data interfaces for particle data, mag, plasma, but you really want to make it language independent and then have language specific instantiations of the interface. That's probably too long, but anyway, I'll stop there.
So one consideration that I have um, is the underlying functionality, the source code for the packages, is that going to be written using AstroPy objects? And the reason why it's important to go deeper is that uh, we want to blur the distinction between user and developer. And if someone is really familiar with AstroPy, with SunPy, for example, if a space physics package were built on AstroPy, it'd be a lot more straightforward for someone to contribute to that package because they have the same common baseline. So that's a consideration.
I will
Yes,
say,
so there's where the use cases come in. Like if the users are from that community, that makes sense. If I don't think a lot of the time series people are using AstroPy. That's uh, we'd have to do like a study or something. So because adding that was part of the discussion in that time series standardization thing is like, whoa, that comes with a huge dependency add. And so if it's only something that you're doing sometimes, it was a big lift dependency wise. So that would have to be looked at, I guess. What's the user base and where are they leaning? So the communities that we work with don't use AstroPy. So that's why the the time series and like magnetic field kinds of analysis stuff. Some of it's earth based too. So
but
go ahead.
why not use AstroPy? I guess is this just for historical reasons because AstroPy is traditionally used for, I mean, okay, to be fair, astronomy, as the name might imply. But I mean, is this just because I people don't feel like they need the capabilities in AstroPy, or
Well,
I'm just trying to understand like what, because obviously we on the SunPy side we made the choice to kind of build on top of AstroPy it wasn't quite from the very beginning, but a long enough time ago that it effectively is, or it feels like it. And that was a pretty conscious choice, and I think it's saved us a lot of work. To be quite honest, it means we don't have to maintain our own time representation. We don't have to maintain our own units package, our own coordinates package. We can just build it means it really relieves the kind of, or it lightens sort of the maintenance burden on us. I mean, of course, it means that we depend on AstroPi, and we depend, there's some non-trivial coupling between SunPy and AstroPi, but I think it has been a huge, huge benefit to us, and it means we're interoperable with anything, any other packages that use the same data types that they do. So I'm just trying to sort of suss out like why people don't, and that's not to say there aren't good reasons, but I
have to be careful speaking for the community on this. You shouldn't consider me a representative, but it's like the issues are, if it was good for remote sensing, it just might not have the in situ stuff in there. Oh, it doesn't have our coordinate systems. It doesn't have our units. It doesn't have our, and so people go to use it and they're like, oh, it's got all this stuff, but it doesn't have my stuff. I think that's why people would turn away.
Sure. Yeah. Well, Nick's had.
Yeah. I'm keeping mine short.
Yeah, for this discussion, I was hoping that we wouldn't spend that much time debating about whether to AstroPi or not. I was hoping that we could talk about, if we accept the premise that we need AstroPi interoperability, or that some people need AstroPi interoperability, then how would we best go about getting it?
I think like the other thing that I think would be really interesting, that the other thing that I think is really interesting about what Nick is proposing is it will provide us somewhere a new package probably, right, to answer the question, okay, what does putting this Helio thing, a unit, a coordinate system, a timescale, or whatever it is, inside the AstroPi ecosystem look like, right? Because while I disagreed with quite a lot of what you said, John, the thing that I do agree with, right, is heliophysicists won't use AstroPi if there's no heliophysics stuff in AstroPi, right? It's a chicken and egg problem, right? People won't use it if it doesn't do what they need to, right? But that's not a technical reason to not use AstroPi. That's a reason why, as developers, right? That's not a reason for us not to use AstroPi as developers. That's a reason that the users can't currently use AstroPi, right? So what happens if we make a thing that uses AstroPi and enables users to use AstroPi for heliophysics, right? And then they can use AstroPi, right? They can just pip install an extra thing that plugs into AstroPi or whatever, right? And now there is the stuff they need inside the AstroPi ecosystem. So, is that going to be useful to people? Like, would people start using it, right? Also, I am just going to say this once. AstroPi is not a heavyweight dependency. It's not very large. It's got three hard dependencies that it has, and it was on the second package on that user survey that Rebecca showed earlier in the week. It's already installed on everyone's computer. It's like 20 megabytes, and it's got a tiny dependency tree. It is not a heavy dependency, and I will now not mention this again.
Okay, well, thanks for correcting me. I'll stop saying that.
I did a fresh install of AstroPi in a new Python environment, and I think the total amount of dependencies was about 30 megabytes, which again, these years is not that much. And it gets us a lot.
I think just to build off something Stuart said too, when before SunPy decided to go all in on AstroPi, in particular in the coordinate space, there were no Stolar coordinate frames implemented in AstroPi coordinates, right? Albert did all of that work. Stuart did some of that work too. To basically, I mean, there were, and it was a back and forth, right? Some things had to change on the AstroPi side, but what it allowed us to do is to basically build off of that existing framework and to implement our coordinate systems in AstroPy. And so now, we have all our solar, the kind of usual solar ones that a lot of us use, but then there are also some Earth-centered coordinate frames that are defined in SumPy, but they are attached to the AstroPy coordinates framework. So that's all to say, just because it doesn't exist now doesn't mean it can't exist. And that goes for coordinates, units, time. A lot of these frameworks are designed to be extensible for exactly these kinds of use cases.
And I want to mention also that uh, creating this package by no means needs a FEP, but I was thinking that a FEP would be a good vehicle to at least explore this idea in depth. I'm thinking also like in a user survey, especially if there are a lot of solar physicists taking the survey, asking, would you benefit from a heliophysics package that is built around AstroPy objects? I have a strong suspicion that there will be a lot of solar physicists, remote observers who would really support that package, or at least necessarily package that functionality.
Right. Realizing that on Zoom you just see an empty podium over here, but if you look around the room, there are thinking faces.
So you're not invisible. Okay.
Although discussion does seem to be slowing down a little bit. Yep. Although discussion does seem to be slowing down a little bit.
I think it's worth discussing what pieces we want on this survey and try to hash out what that looks like.
I think what we're missing a lot from these types of discussions is, and Nick pointed this out in the slides, is sort of where in these type of kind of in situ plus remote sensing, these workflows that sort of span the from, I guess, sun to mud is what we're calling this. Where do things fall apart with our current ecosystem? Like where are the kind of pain points? And I think that would help to illustrate like whether, in the context of this now proposed idea, where are the pain points in that type of a workflow, and then how does using these common AstroPy objects like we're proposing, how does that fix the problem, right? I think that kind of makes this more concrete. Like if we have something like this non-equilibrium ionization modeling in a CME type example, can we try to use like the existing tooling, show where like they're like kind of where the friction happens between our existing tooling, and then, if in this kind of utopian vision, how is that made better, right? I think that's a kind of a hard thing to do, but maybe an interesting like proof of concept, and would help to like make all of this a lot more concrete. Like I think obviously a lot of us have been kind of espousing the benefits of AstroPy for a while, but I think what we are often missing are sort of concrete examples of where in workflows that are sort of outside or adjacent to our community, how they're really made better by using these higher level objects.
Go ahead, Nick.
Thanks. Yeah. Crap, I forgot what I was gonna say. Come back to me in a moment.
No worries.
I think those kinds of use cases are the ones that, with the time discussion, that was, I know Bob Weigel's not here, but that's what he was pushing for and saying we need to do test cases to see what the impact is. And it's a very different kind of analysis. And so does it really work with um, very high density time series analysis? So maybe it does. So we need to show that. And I think that would give people a kind of comfort level with it.
Go ahead, Nick.
Thanks. I remembered. Um, Building on what Will was saying, one thing that I've been wanting to have happen is like having a prototype for this, or a proof of concept for a high level object that could encapsulate um, the heterogeneous in situ space plasma data. That would take a couple months probably.
So the time series object in SunPy sort of handles this, right? Where it falls apart is if you have uh, like a higher dimensional um, data, like for example, like a velocity distribution in time. Like we can't handle things like that. But if you have, just like bx as a function of time or whatever, it can handle that. And there is some, we have some time series sort of functions like map in that it can handle multiple sources, but then exposes all these uh, time series data through a common API. But it's much less featureful than map is, and that's largely just a function of the scientific interests of the people who have worked on SunPy for a long time. Like most of us are kind of remote sensing, first scientists, and we don't do as much with in situ data, but it would be great if there was sort of more first class support for these kinds of data products.
Yeah, the higher dimensional stuff would be a must, right? If you have an particle energy spectrum, or particle energy and pitch angle spectrum, or and then there's complexities that about things like people mentioned, I think it was Speedos folks mentioned about changing the bins as a function of time for the spectra. That happens with radio plasma wave data and energetic particle and plasma data. I mean, plasma data itself, like density, temperature, velocity, those are based on and derived from underlying energetic particle data, just much lower energy distributions. So the energetic particle data has to play a fundamental role in that. It has to be well represented. Now, is John Niehoff still there? Because he worked on a way to capture this in CDF data better. And he's gone. Okay. Yeah. So there's people who've tried to think about how do we standardize a representation for things as complicated as the particle data. So yeah, they would need to be significantly involved, I think. Otherwise, the lessons learned over multi-mission representation of that stuff would be lost. It's not as difficult for the derived stuff like the density, temperature, velocity.
Is there anything that, for anyone who hasn't said much this conversation, any burning topics that they'd like to bring up?
Thinking of other core package areas. We have Jim from PySpeedos, Jonathan with PySat. Do y'all have any thoughts? I also see Darren's online.
This is Rebecca again. Sorry. Proposing a way forward. What if we have a notebook where we have some sort of example science analysis that encapsulates just one of these ideas? And that maybe it's on HelioCloud, whatever y'all want, okay? but that can be a way to work out what this looks like now so that the software developers among the packages can take a look and see, is this acceptable? Is this okay? That could also be, you could also try to get some users to see what their opinion is on that workflow. Like, first of all, is the science quite right? Do they have opinions on this versus that? There's those things too. But also, is this easy enough for you to understand what's going on without having to dive deep into the documentation? What are the thoughts on that?
Would this be tested out at one of those user workshops we talked about? If it's polished, sure. Okay.
Yeah, I like that idea. I think it could end up being a large amount of work to do that. Though all of this is a large amount of work that none of us have funding for.
Could we leverage some of the summer school stuff to try to make it easier?
And one possibility would be to do a NASA HTM proposal to do a prototype for this, which would involve like going through the software engineering steps, including things like what Rebecca mentioned.
Sure, yeah.
I mean, I think we could also sort of start from like the top down, like, or I don't know if that's the right way to put it. Start from like I want to do a science, right? and then not necessarily worry all that much initially about like the details of like whether it belongs in a package. Just start trying to answer a science question using this sort of proposed stack, right? Like, okay, we have, so like I'm just gonna run with your NEI CME example, Nick. Start trying to do the non-equilibrium ionization modeling with the tools you have with Plasma Pi, maybe with Fiasco to do like the atomic data. Okay, both of those use units. Great, love that. Put it in a time series object with a coordinate that understands like the trajectory of your CME, for example. Then have like your spacecraft trajectory, as exposed also by an AstroPi coordinate, maybe as computed from a spice kernel or something like that. And then, try to do your analysis using these existing and just, see again, like where are the pain points. And by when I say do and you, I mean just someone. I understand like this also is a non-trivial amount of work, but I guess what I mean is I think we should just do something and not worry too much about formalizing it, but just as sort of a proof of concept to see. Formalizing it in terms of like a package and all of that. Like those, leave those details to later, but just to see, does this work and where does it more importantly, where does it not work?
What if you find a postdoc or other scientist that has this problem? They're trying to do some sort of science analysis along these lines, maybe not exactly, projects vary, but something close enough. And then this can happen where they're driving the science and we're more, well, PyHC and these packages are more of a support.
Yeah.
Am I trying to do things for free? And that's not a good idea, but I don't know. Shoot me down if it's not good.
Yeah, I like that idea, especially since it involves other people doing work and not me.
Yeah, I guess it would be interesting to find cases where people are sort of bridging this like remote sensing and in situ observations, right? That's not something that I do, but there's people at Goddard that do. I think in general it's just a challenging problem. No matter what set of tools you use, like it's a hard thing to do. And I guess the question is, to what extent does this proposed stack make that easier? And yeah, I wonder. Actually, Nick, I think Sam Badman, right, does a lot of this sort of like back mapping stuff, like from like PSP observations, back to like what's the source location on the sun, right? Using, for example, what is now SunKit MagX, what used to be PFSS Pi, all of which are expressed like right using these coordinate objects. So maybe he's a good place to start. Or just asking the question, not asking him to do work, but asking the question of like how does this, because I think ultimately that's what we're talking about is there's clearly a divide in like the software communities, but I think it's also because there's a divide in the scientific communities too. And we're trying to sort of bridge both here, which is a challenging thing to do. But clearly he's been successful in doing that. So
Yeah, he's also at the CFA, so I'll try to remember to ask him next time I see him.
So I'm sorry if this is crazier, but what if we had a part of the spring PyHC meeting dedicated to science presentations that are attempting to use the packages in such a way? And the requirement would be you have to have, oh, Nick, you like my idea. You have to be using remote and in situ data in your science and be in heliophysics. And then we will give you, well, with Julie's permission, Julie would decide whether it's relevant enough. I'm trying to not cross lines here. I don't want daggers. Okay, fair point. They would get a presentation and it would be a competition. And whoever wins the competition, y'all decide how the vote goes, gets an afternoon hackathon dedicated to supporting their work with PyHC packages and the developers in the room. That seems like a cool prize. If talked to me 5 years ago, I would be on deck from a science perspective.
Yeah, that sounds really fun. Along those lines, making it like interdisciplinary, because there's also things like space physics work, which is trying to compare to laboratory plasma experiments also. I have a bunch of use cases for that.
I'm generally a big fan of the idea. I think that that would be an interesting way to inject some new perspective.
Yeah, I think the hard part there would be finding such people who are doing that kind of work. I mean, we could just blast out to the PyHC email list and ask, hey, does anybody meet this criteria? But if that didn't work, I might be a little bit of a loss for how to find such candidates.
Summer school students.
Helionauts, AGU, summer school students are ideas that just got pitched. And those are good ideas.
Yeah. On top of the AGU, I mean, there's all of the Gem, Shine, CDAR people. There's especially with the students and doing their presentations, hitting them with some sort of request for people doing interdisciplinary or just people at those edges where there's always people who have to sort of make up their mind if they're doing one or the other, if their work doesn't quite fit neatly into one realm. And those are the people that are most likely to use multiple packages here. You want them to work together.
Alex, I see your hand is up.
Hey, hopefully this will work. I had to go out grocery shopping, so I'm doing this from my phone. Um, so I guess my question kind of related to what Rebecca was saying, and it connects to several other people, but I mean, this could be part of what the job of sort of the outreach component of HDRL should be doing. I mean, that's what I'm doing with Brian and trying to find out, and I say this also as a user. I'm not a developer. I'm a astrophysicist and a solar physicist. Um, but making this part of various things that Rebecca and I are trying to do to get input from users. So just putting that out there as a avenue, both with some support. I get support from Brian to do this kind of stuff.
I like that.
Same.
And also this helps me drive what kinds of things should I be doing to support the outreach. And when I say outreach, for everybody to know, I'm not talking about public outreach. I'm talking about community internal outreach.
Sure. John.
Yeah, I mean, we can be on the lookout at the AGU and other meetings for people that have cross-disciplinary output and try to, coax them or approach them. Hey, would you be interested in giving us your use case or letting us look over your shoulder?
Yeah, and there's certainly a lot of people. I mean, in solar physics, you have people that are trying to understand BZ and ICME by looking at the in situ data and also trying to see if they can connect that to remote sensing. I mean, that's obviously a huge problem people would love to solve. Or there's certainly a lot more push for cross-disciplinary work between, if you're doing planetary work at Mars, but you're also going back and looking at the sun. So you're using MAVEN and so on and so forth. So there's certainly a lot more cross-disciplinary use cases that we could solicit for interaction.
Nick, go ahead.
I was thinking also we could use like NASA ADS, soon to be SciAx, I think, to look for research projects where they cite multiple PyHC packages.
That's good in concept, but the problem is people don't really cite software packages yet. And the experience I've had with trying to pull research from publication to notebook with the authors is they've moved on. And 6 months later, they can't remember how things work. So there's that. I love the idea though. I've had trouble with executing it though.
Probably at least worth exploring the idea. And like kind of along those lines, having a list of publications maybe on the PyHC website that use PyHC packages, especially multiple PyHC packages together, could be worth at least thinking about.
Definitely.
And we've been talking about this for like 45 minutes, which was the allotted time. So just wanted to mention that in case scheduling stuff.
No, because John's went shorter. We have more time if we want it, if it's needed. So do we still need maybe a user survey if we're going to be pulling all these ideas into our spring meeting potentially? Just creating this user survey still makes sense.
I really think we should do it.
Okay. Yeah.
Possibility even would be having a hackathon session focused on that, though unfortunately I won't be able to join you since I have proposal writing to do. But after December 2nd.
No worries. Maybe, there's a 16th, I think, of December telecon. We could just use that time. No, that's after. Yeah. Sorry, Rebecca asked if that's during AGU. And I very specifically did not put it during HU.
I think that'd be a great use of a telecon.
All right, it's on. Be there. Don't go on vacation just yet. Show up and then go on vacation at 10 a.m. Mountain Time that day.
Alex, do you mean to have your hand up still?
No, sorry, I just can't figure out how to put it down.
I just
I'll
did.
figure that out in a sec.
All good.
It seems as the one in power, I was able to do it, so you don't have to worry.
I think one closing thing for the topic of this GitHub issue is who in PyHC is like really interested in exploring this idea further after December 2nd.
How do we get a handle on that? Do we raise hands? Do we raise hands, or how do we get a handle on that? We could raise hands in the room, but you wouldn't see us.
I can tell the podium's not interested. Yeah, I think I'll post a thing in Slack, and then you can respond there.
Yeah, that's a good idea.
Sounds good. Thanks, Nick.
And I'd be interested to talk with you about it further, just to see how happy stuff could be adapted into it, or how this idea of the science data interfaces fits in with, because that's, again, it could actually be just an adapting layer itself into whatever, if you make something else. So.
Yeah, and I haven't said this yet just because it was kind of a non sequitur, but I feel like it's worth saying that I applaud this effort, and I'm happy to see that there's at least interest in starting it. Because I think this is a great example of the kinds of ways that PyHC can foster an interoperable thing and make something that's super helpful for everyone and solves the problem, but without us having to, do community-wide mandates or involve other people that don't want to be a part of it. I think this is just an excellent way to tackle that kind of idea. And thanks for having this idea, Nick.
Thanks. Yeah, this turned out to be like a really good discussion. A lot of really good ideas.
Totally agree. Do we have any other final thoughts?
Thank you all for being awesome.
You too, Nick. Thank you. Okay. Well then, we can go ahead and wrap up that idea. Looking at the beautiful schedule, the next thing that's up is voting for, I believe that's 2 and 3.
Yep, that is what's up next.
John's out, so I'm just gonna have you lead that if you want to come up here.
Yep, I can do that. Can I suggest maybe like just a 5 or 10 minute break, just since we're ahead of schedule here, and just give people a sec?
Yeah, we can do a quick 10. We'll be back in 10, so 11:10.
Cool. Quick 10-minute break.
Okay, we have the main star back. I just want to say before Sean starts, please put the voting in the threads that are on Slack so that in-person and virtual can all be in the same spot.
Yes. All right. So, let me see. Am I visible and audible on Zoom? Okay, there we go. Seems like it. Great. I think just to introduce this for a second, really this is just the voting, so it won't take but a minute, but just to make sure everybody is on the same page, I'll try to quickly open up the
the FEPs that we're talking about in GitHub real quick and share the screen, just walk through like the abstract and then we'll do the voting?
It's in general. I just put it in there.
Yep. So yeah, and while I'm pulling up the links, yeah, if everyone listening to my voice can go to Slack and go to the general channel, there's gonna be two little threads, and you're gonna be posting a yay or a nay as a comment in that thread.
Yes, we need an actual yay or nay, not a thumbs up for my sanity. Thank you.
All right, and then I can share my screen here. All right. Oh, fascinating. This laptop is in dark mode.
It's
Okay.
on my Google Chrome profile.
Ah,
I don't
nice.
like light mode.
All right, so hopefully people are seeing GitHub on Zoom here. And the first thing we're going to be voting about, this is incredibly straightforward. I think it is just a template for how to use FEP1. I can ask the people in the room here, is anybody seeing this for the first time, or have you all at least seen this once before? Well, Isaiah hasn't seen this before, yes. But raise your hand in this room if you have not seen this before. Okay, good. Thank you. Just wanted to make sure that that's happened. It's a pretty cool thing where it just has all the same sections as FEP1, and inside each of them is a little example, a little explanation of what the section is supposed to do. And it's totally self-explanatory, and this FEP2 is itself a proper FEP. It's a little meta, but yep, it's an informational FEP. This is just a template for how to write a FEP. And in fact, I used this and Julie used this too to start when we did FEPs 3 and 4. So, nope. Well, no, I mean, I won't say flat out no. There actually is a revision process outlined in FEP1. But kind of the main reason why we want a template that's short and sweet like this is that FEP1 was like a very monolithic document, and it's kind of hard to parse. Yep. So then by all means, if it doesn't matter that much, then just vote yay.
It's for the process. A FEP is a FEP is a FEP.
Yep. So, okay, anyway, so that's what we're voting on first. So now I will give us just a couple minutes to go into Slack and vote, please. See, I'm going to be watching just to wait until I see everyone in here has put down something.
Looks like we're waiting on Jonathan to vote. At least from online.
Yep.
Yep. I think I'm seeing everyone's name in here except Jonathan. If you happen to be in earshot and feel like doing this, I'll give you like 30 more seconds to give something. Going once, going twice. Okay, sold. The vote passes. Woohoo. Round of applause. Thank you, Julie. All right, and then the next one we're voting on here is going to be FEP3, which has more substance. One sec, pull requests. Here it was. All right, so this one here, FEP3 adopts spec 0 for PyHC is basically what it comes down to. We added on one extra bit, which is a 6-month recommended support for new versions. I'm going to go ahead and read the abstract out real quick because it covers the ideas. This FEP recommends that all projects across the PyHC ecosystem adopt a common time-based support for dependencies inspired by spec 0, specifically for Python versions and the upstream scientific Python packages covered by spec 0. It recommends that projects support Python versions for at least 36 months, which is 3 years, after their initial release, support upstream core scientific Python packages for at least 24 months, 2 years after their initial release, and adopt support for new versions of the dependencies within 6 months. And we are going with just the core scientific Python packages that exist in spec 0, just to not expand the scope beyond spec 0. And those are listed here. I'm not going to read them out. And then this does replace the current standard number 11 in the standards document. And that'll just be updated, and there'll be a link to FEP3 to say this is the new policy. Yep, and I think I can go ahead and click number 11 to show what that says. Yep, all we had before was just Python 3 recommendation. So the packages must be compatible or working towards Python 3 compatibility and provide ongoing. Yeah, that's pretty much it actually. So this is just a nicer, more robust thing to keep our dependencies in line, and spec 0 is what's recommended. So yeah. Anyway, there's a hand up in the room, so we're going to get a microphone over real quick.
I appreciate that we have a dependency problem here, but I feel like I don't feel like this goes far enough, right? Like I feel like given the tiering stuff in FEP4, I would say that this should be a must and apply to silver, right?
Yep.
But we're writing it as a should, and FEP4 doesn't exist yet.
Yep.
So I don't know. It feels really like an impossible problem to spiral out of. But there's two things that I would want to change about this. I would say the packages must do the things that currently listed under the specifications section of this FEB, because they're not actually that onerous at all. Like they're not forcing you to like drop things. They're just forcing you to pick up new ones. And the other thing I would say is that we should say that packages should also apply this to all of their dependencies, and leave that as that. But that's a different argument. The main thing I want to say is that if FEP4 existed and we could attach this requirement to a tier from FEP4, would people have a different opinion about whether this should be a should or a must? Because I certainly would.
And I certainly agree with you. I wrote this as a must initially, and I had slightly stricter language actually all throughout the document. But I immediately got pushback by a couple people. I'm not going to call out names, but some of the first comments, if you go back and read the comments, are people saying, no, don't make this a must. I don't like this. So it wasn't going to pass unless I made it a should, which is why it ended up being this way.
It might not pass if you don't make it a must either. Right? That's a circular problem, isn't it?
But it is, if I can just open up the thoughts in my mind a little bit, I am planning on using this as a starting point and then growing this closer to a must and including other dependencies in the future. But that'll be like, maybe this will sit like this for a year or something, and then I'll come back and revisit it later. But just, yeah, based on the GitHub conversation, this was what people could agree on.
But if that's the plan, I mean, and then to change a FEP, you still have to have consensus, right? And so then it's just, you're just going to fight the same battle in a year or 2 years or 6 months or whatever.
Yep.
Right?
But my hope is that after we've had this running for a while and we can prove that it's been helping people, then maybe the people who had dissenting opinions this time will have changed their mind the next time.
I think I'm just like reading back through the GitHub discussions. I don't see how that. Oh, I don't know. Fine, whatever.
Here, there's a hand in the room.
I have a bad history with those kinds of things from teaching. Thinking back from being a software developer, this looks like just good practice. So I think putting it as a should for now is fine. The thing I picture later is that this becomes a should for bronze, for instance, and this becomes a must for silver. Because the things that you're supporting on here, first of all, it's if you depend on this supported. Not that you have to depend on all of these things, but that's it. That's my thought.
And actually, this FEP has actually specifically been called out by name in FEP4 as criteria for tiers. Like, I forget if it was silver or gold, but to be a part of the gold or silver tier, you have to comply with the shoulds in FEP3. So there will be some kind of mechanism for if you want to be at a higher tier, you got to be following this. So, okay. Without further ado, I am going to open up the voting. We've already got a couple of yays in the thread. Thank you all. But let her rip. As PyHC's tech lead, I accept gifts as yay. Mm-hmm. All right, that's just about everyone. I'll give it another 20, 30 seconds. Going once, going twice. Voting is closed. Thank you for the abstains, Julie. All right. And FEP3 passes that vote too. Thank you all for participating there. So I know for FEP2, we already did a vote on that. So FEP2 is ready to merge now. I'm actually not remembering if this is the first or the second vote for FEP3. I think it might be the first. I don't remember ever putting it to a vote. Yep. So I will go back and confirm that. But cool. So I will start the process of merging FEP2, and then I'll clarify what this is. And if this was the first vote, like I'm thinking, we'll have the next one announced within a month before we actually hold the vote, because that's our rules.
Can I make a suggestion for future process here? I think these votes should be on GitHub. Just because then there'd be a public record of them on the FEP forever. Like we should do this as comments on the PRs or explicit approvals on the PR.
Yeah, that's a good idea. Actually, because you mentioned that, I want to go look at the pull request for FEP1 and remind ourselves how we closed that out. Yep, so yeah, I agree. It would super help if we did this in GitHub in the PR next time. So I will make a mental note to do that. Thanks for the suggestion. All right. And that ends that bit. Which now, if I'm looking at the schedule here, gets us into a wrap up and then lunch.
Okay. I just have a few slides. Oh my God, get rid of that one. This is in full screen. That's why that's hard. Okay. Now let me hide this. That's annoying. Okay, cool. We Gucci now. All right. Well, you made it to pretty much the end. There's an optional hackathon, well, hacking session, I should call it really, in the afternoon if there are some things that people want to work on from this meeting. The room's also just booked out. So if you have things you want to work on, it's open and free to you. Okay, so upcoming meetings. I do have a kind of general question I wanted to run by people. So spring 2025. Normally, this would be all virtual. It was brought to my attention, which is valid because I felt it too, that there are a lot of in-person meetings that have just been generated in the fall. It started with AGU, always being in mid-December. Now there's DASH. There's the USRSE now having their annual conference. There's a lot of things going on in the fall. Do we want in the future to switch to the spring meeting being the hybrid where there's an in-person component and let the fall just be all virtual to avoid too much in-person meeting fatigue? I have one thumbs up. Would just love to get the temperature of the room. We have thumbs up. I don't cares. What saith you online? If you can just unmute, that would be great.
No preference.
Okay, cool. All right, well, hearing no immediate horrific dissent, maybe we'll just start with this next one being hybrid. So that means 2 hybrids in a row. Sorry about that. But then next fall, it'll be just an all virtual. So something a little bit simpler to keep it easier for us. And obviously this year's fine, but the year after there'll be a summer school. So we can discuss how we want to handle that. If we want to have it be like the week right before, if we want a month or 2 separation, we'll figure that out that year. So not going to worry about that right now, but here's your forewarning, sometime in May. All right, other upcoming meetings, AGU, we have a PyHC poster session, so if you will be at AGU in person or virtual, feel free to check that out. It's on Thursday afternoon. And I have a list of at least the talks or posters I know about myself and Sean. If you have another talk or a poster that's not involved in our poster session, message me. I'd love to get a list going so we can make sure we support each other's work. Okay, other question I had. At some point, John Niehoff went through the trouble of putting together a Google spreadsheet with upcoming meetings and potentially who might be attending. Has anyone looked at that since that happened? Does this even ring a bell?
It rings a bell. I have not looked at it personally.
Okay. Maybe we remove this task from John's plate if it did not prove fruitful for people to go ahead. Becca has a comment.
I shocked the mic. This is not unusual. Maybe instead of such detailed work, what we could do is just have a list on the PyHC website. Like you might come find us at this list of meetings we commonly attend as a community.
Yeah, that could work. There's also our calendar, which shows upcoming meetings. I mean, it's a bit of, there's two calendars. There's our calendar and then there's the, oh God, what's the one that Barbara manages?
Heliophysics events, I think is what it's called.
Yeah, that one has like any helio relevant at all meeting that you might be interested in attending, including all sub-science disciplines. But the PyHC one tends to be more focused on the ones that our community is involved in. So we can just stick to that, and John has one less thing he has to do. I'm a fan of that. Okay, upcoming telecons, we have a few more. So this coming Monday, we'll finish out that FEP4 Miro board. I really wanted to go through the benefits with everyone and agree on what we want at what level. So thank you in advance for dealing with that. The second, maybe we can hash out licenses so John can write his FEP eventually about this. If there are other topics, I'm totally open to bringing those on. As we mentioned earlier, on the 16th, that's the last one we'll have of this year. That'll be going through that user survey and kind of workshopping that to help Nick out and us for our upcoming spring meeting, getting things going. Just general temperature of the room, 2025. Do we want to start on the 6th or 13th? I don't know if people are still on vacation. The second option? All right. Yeah, we'll start on the 13th. We'll give everyone some breathing room. I'm fan. Okay, just some recaps. I still need to go through and look through my notes and listen to the meeting recordings. There are takeaways I'm missing. But for interoperability, I know, Sean, you have a task to work on getting the package tests into the environment. There's the package user survey, which we'll be working on soon. Summer school interoperability, which, we've talked about using that as a starting point, maybe testing this out in an HDRL user workshop. Maybe this just goes away with what we do at the spring meeting, something to talk about. As far as FEPs go, we had a lot of talk about FEP4, so I need to go and update that, and then people can give their thoughts on the updated version. We have the standards FEPs that John and it'd be great if people could help them out with that, can start putting together. And then some PyOpenSci specific FEPs based on the conversations we have with FEP4. So I probably won't write those until we have FEP4 more fully concrete. Other things, come to the telecons, see us at AGU. And if you have any kind of overall takeaways for the meeting, format, content, anything, whatever you want, just keep it nice. If you go to the general meeting notes doc, I put a little takeaway section. So throw those thoughts in there. And finally, a thank you for getting through this week and being a participant in all of our very fun discussions. Good job. All right, you can go eat now. It's just kind of open. Come back and work as you want. If there's something you want to organize in this room, it's open. I'm not going to put too much structure on that.